canvas of the cosmos, our dreams, pains, constellations of possibilities. To enlighten the curiosity, here comes the 65th webinar session Earthquakes, the most devastating disaster. Today, we got an eminent personality, Dr. Ganesha sir, as a chief guest. Me, Dwayne, a student member of US Space Club, is thankful to welcome you all. After the tremendous spread of COVID-19 virus, our US Space Club decided to conduct webinar sessions on every second Saturdays to nurture the curiosity of the enthusiastic students. Under the leadership of E.K. Kutisa, the former director of ISRO, also the founder and mentor of US Space Club, have become a great platform for students to encourage their dreams and to explore our universe. By the strong support of eminent personalities like Jayaraman sir, former Deputy Director of ISRO, Rangarajan sir, T.K. Sundaramurthy sir, and by the constant guidance of teachers like Shajil sir, Damodaran sir, Sandesh sir, and also by the support of Dr. Shahin Tahir sir from University of Calicut and Dr. Sujit sir from NIT of Calicut. Also, by the immense hard work of student coordinators, our UL Space Club had grown into sky. I welcome all these distinguished personalities to this wonderful webinar session. With immense pleasure and gratitude, let me welcome our chief guest and speaker of the webinar, Dr. K. Ganesha Rajasa, former scientist of ISRO. I welcome the distinguished group of scientists from ISRO present here. I extend a warm welcome to our Kuti sir, founder and mentor of UL Space Club. My heartfelt welcome goes to Shajil sir, the moderator of this webinar session, also the light of a UL Space Club. I welcome all the members of UL Space Club, coordinators, and well-wishers. I cordially welcome all the attendees to this wonderful webinar session. There are a few reminders that make sure that your microphone is off during the presentation. If you have any doubt, you can ask in the Q&A session held after the presentation. You can post your doubts in chat box by introducing yourself. And this webinar is followed by a UL Space Quiz. Quiz link would be posted by the end of the session. The first prize winner would be honored with a prize sponsored by Sindrabi Nurture. Once again, let me invite, welcome each and everyone to this webinar. All the best. Let me invite Shajil sir for further introduction.
Thank you, Dhani, for your nice introduction and welcome. And we are proud to be
Thank you,
here
sir.
for the past 64 weeks. We have been sitting here at the banner of UL Space Club with the support of scientists from various fields, including ISRO and other higher education institutes. Today, we are discussing a topic that is most relevant, most threatening, and we have to be aware of those things in much more details. That the earthquake, it's a natural phenomenon. You know, the science is the way to explore the phenomenon and the universe and all the secrets around us, and we are knowing with our experiences, and we have severe experience of Valdivia earthquake in 1960 that was around 9.5 like that of magnitude, and we have an Indian earthquake that's a severe one that was in Bhuj in 2001. And fortunately the Keralites are not aware of these things, but in Indian perspective we are much more concerned about this natural phenomenon in a humanitarian consideration. Anyhow, today we have the speaker from ISRO who have been working for these kind of geological and geographical explorations through our space technologies, Dr. Ganesh Raj. Let me proudly introduce today's guest for our viewers, that Dr. Ganesh Raj, and he's from Kasarkod, and he's a graduate. He graduated in geology and postgraduate in the same subject, and he's a doctor of philosophy and geology from in the remote sensing and applications in Quakes from Gulbarga University, Karnataka. And he started his career with ISRO in 1984 under the National Natural Resources Management System, NNRMS. The major areas of working included groundwater, environment, geology, land and water resource management, earthquake, landslides, and city planning, societal applications, etc. He worked as program manager of Village Resource Center program of ISRO, and he was the director of Respond, of sponsored research at ISRO headquarters, interfacing with universities, institutes, that towards the sponsoring research of projects of relevant space program. Worked as General Manager, Region Remote Sensing Center, RRC South, NRSC ISRO, and he retired from service in 2021. And he was consultant advisor of CSR activities till August 22 and a new Space India and NISL. And he published more than 130 scientific papers in international, national, and journals and more than 70 technical reports along with that. And he is honored with the awards of Rajiv Gandhi National Drinking Water Project and his contribution in Village Resource Center program and ISRO Astronomical Society of India Award in 2019 and Space Science. And he received this Team Excellence Award for these kind of activities and his contribution to the nation. And he's a fellow of Karnataka Science and Technology Academy. And he's the member of Science Society of Remote Sensing IRRS, Environmental Association of Bengaluru, and Astronomical Society of India. We could proudly say that we have an expert to speak regarding this earthquake in India. He's an expert in this field and he's explored a lot of information for our security and our safety to take precautions to well aware of these natural phenomena, these seismic activities. And I welcome Dr. Ganesh Raj for delivery speak, and I welcome all the veteran scientists and the students and teachers gathered here. And Ganesh Raj, sir, please.
Thank you, Dr. Sajil, for a wonderful introduction of mine. And thanks to all my seniors who are attending this talk, Dr. Jayaraman Bhatt, Rangarajan, all seniors, and all students, Dr. Kuti, Sajil sir. I'm thankful to you for giving this opportunity. In fact, I'm supposed to talk this on October 9, but due to some personal problems, I could not give this talk. So Kuti sir requested me give the talk online. And today I'm going to talk one of the most dreaded disaster, earthquakes. No one knows when it will strike and what will happen. And as recently as a week back, there was a major earthquake in Philippines. So let us see what is this earthquake. I hope slide is visible. Okay. But not in presentation mode now. Okay. I have done that. I will again try. Maybe I have to share again 1 minute. Now it has come. One minute. I will share again. Maybe that is the better. Because sometimes that's what I've observed. Yeah, that's what I'm trying, sir. Is it visible now?
No.
Full screen? Oh. Because for me it is coming as full slide, that's why. 1 minute, 1 minute. Because for me it's coming full screen.
Sir, first you make the share screen. Then you can go for the presentation.
done,
It
sir.
will be coming.
That is done actually, but
No. In that case, that screen will not be coming. You are yet to select the file.
no, sir, I have done that. That window is not visible here. That's what happened. Yeah. Because I have done that. For me it was visible, but it is not coming.
Sir, other option could be you send the file through mail to Sajil sir. He can change the slide.
I have done that, sir. I sent to him already. If not coming, he will do that.
Okay.
Just come, sir.
Full screen is not what you are visible. Otherwise, you can continue.
No. But for me, it is coming full screen, sir. Slide is changing. Full screen is visible.
No.
Then I request Sajil sir, why don't you share? Please share, yeah. Okay.
You can continue to talk, that's not okay.
Yeah, I will need 1 minute, sir. Okay, of course, earthquakes are historically or mythologically known for a long time. And we have a lot of mythological evidence also. There was a lot of earthquakes. And traditionally, it is believed that Earth is held up by several elephants that stand on the back of a turtle, that is Chinese and Indian. And Indian even thought it is on Adishesha. The turtle is balanced on quick release of its. This is the most disastrous among natural hazards and disasters, originated in a limited area and spread in all directions. Give rise to various secondary hazards or disasters like tsunami, which we had in bitter experience in 2004, avalanches, landslides, subsidence, fire, and flood. Of course, the slide, as I thought I explain more, because the oceanic crust, and the plate, how it moves, there is a different areas how it gets submerged, or there is the diversion it happens. Because of this all activities, there is a constant movement, of course very slow compared to our regular movement, that causes large number of earthquakes. I think the slide is visible now.
Not changing. Slide is not changing.
Not changing, sir. I think some bandwidth problem then, because for me, everything is happening, but I think it's not going to through the network. For me, all are changing, everything is happening.
intention of the event itself, the intensity, the location and the intensity.
Okay. Because I'm not able to. For me, it comes, but it is not beaming. It is not streaming. I'm able to see full screen only, but it is not coming full screen for all of you. It has come. No, is it? But not. Is it the full screen? Yeah, I think it's okay, sir. We will go ahead. Yeah, sorry. Yeah, next slide you can go. Of course, this also explained. We will go next slide, sir. Because this was the most important slide to understand what is earthquake, the plate tectonics concept and continental drift, which gave a clear idea. Previous slide, sir. No, previous. Yeah, previous slide, sir. Okay. Yeah, so this is what the main side which actually you can understand where all earthquake occurs and what is the basic reason, and the movement of the plates, the oceanic crust, and continental crust, as well as various regions where it gets destructed when it is constructed. That is the area where you have more number of earthquakes. And next slide, I want to show. Next slide, sir. The interior of the earth, because as Jairam sir was discussing in the beginning, out of the 6,400 kilometer radius, we are not able to go beyond 15, 16 kilometers. And whatever our knowledge is based on the indirect studies by earthquake waves itself, primary, secondary, or tertiary, then by volcanic eruption. This only gives some idea about what is the interior of the earth and some modeling aspects. So we have a crust which is about 100 feet, 100 kilometer thick, and we have a mantle, then we have core. So we have not understood the interior of the earth well, but at least what happened for the last about 6 to 7 decades, we are understanding about the plates that is about 100 to 150 kilometer thick continent plus mantle upper part has enabled to understand better way the earthquakes, volcanoes, and tsunami genic earthquakes on the global context. Next slide, please. So this is what the seismic. Can you make it full screen, sir? I'm not able to see full screen. That's what I think problem with this only I'm facing. Here also I'm able to see full screen, but it is not going as a full screen. No, you go to. No, you can go to that menu and make view full screen. View full screen. This we can open here, sir. So we can view full screen. Here, this left corner, left. View full screen. Yeah, here. Yeah. But is it visible now? Full screen? Okay, I think I will go ahead. Next slide, go, sir. There is some network issues there.
Now it's full screen.
Yeah. Okay. Next slide. Yeah, correct. Yeah. This is what just explain. Next. Yeah. What is seismic waves? Because you all know earthquake occurs at great depths. It varies from a few kilometers to 700 kilometers in the Benioff zone. The point where it origins is called focus. The point directly above the focus is called epicenter. And this picture shows there is a movement of the rock on both sides and along the fault. This area has gone down, this has come up. Because of that, there is earthquake here, energy release. And it released the primary, secondary, and tertiary or surface waves. That's what causes damage. So, next slide. Next slide, sir. Yeah, this is what the waves actually, the primary waves, which is basically compressions, expansions, and S wave. Secondary waves, wavelength. Basically, it cannot travel through liquid. That's why we came to know the outer core is liquid. And relic wave as well as love wave. These two are most disastrous waves, which is basically the surface. It creates havoc for the buildings or constructed any type of activity. Next, please. Yeah. Of course, I think this is the seismic waves. I will not go through in detail. As I told you, primary waves, secondary waves, and surface waves. The surface waves are actually love and relic waves. They are most disastrous compared to primary and secondary. Primary and secondary does not cause any damage, whereas the surface waves are the most destructive ones. That's why shallow earthquake is more dangerous compared to deep earthquakes. The shallow earthquakes allow more surface waves because it's very close to surface, which undulating type it moves and it causes serious damages. Next, please. That's what, one minute. S waves cannot travel through air or water, but are more destructive than P waves because of their larger amplitudes. But surface waves are similar in nature to water waves and travel just under the Earth's surface. They are typically generated when the source of the earthquake is close to the Earth's surface. Although surface waves travel more slowly than S waves, they can be much larger in amplitude and can be the most destructive type of seismic waves. That's why shallow earthquakes of 10 kilometer, 15 kilometer, etc. is most dangerous. Next, please. And how earthquakes are measured? That is, of course, you might have heard 3.5 magnitude earthquakes occurred, 6.2 was told. So magnitude is basically the measurement of the earthquake's energy release. It is found out by Richter, scientist Richter. Professor Charles Richter. He developed a scale where it starts like 1, goes on, of course, above 9, normally not required, 9.5 is maximum. It doesn't have upper end actually. So time, location, and magnitude are determined from the data recorded. So seismometers is that records all this data. Then based on that, we analyze what is the magnitude. Magnitude of earthquake can be measured, and anywhere. If there's a earthquake in US, we can measure the earthquake here also, because it is based on the primary waves which travel at the speed of light and reaches everywhere. And the time and one minute, sir. Stop. Can go just stop. Yeah. Magnitude is the size of earthquake, and earthquake is single magnitude, because sometimes they tell moment magnitude, body wave magnitude, a lot of descriptions are there. That is for research purpose, but normally one value is given, like 7.5, 6.5, 9.2, like that. That one important point is the energy released from 1 to 2 is not linear. It is exponential. It is almost 32 times more than the previous one. So energy released by each one, like if it is 5, 6 is 32 times more. So that is what the magnitude indicates. Next, how you really, for a commoner or to assess, there's one more scale called intensity scale. Please go ahead, sir. No, please, further up, sir. Intensity scale, further. Intensity is a qualitative measure of the actual shaking at the location during an earthquake. Like I felt ground is shaking, or window rattling, or building collapse, like that. So it is measured in by modified Mercalli intensity scale, as well as MSK scale, the Medvedev Sponhar-Karnik scale, which has 1 to 12. 12 is most destructive, total damage. 1 is only someone feels like that. There's a clear scale is there, intensity scale. This is very useful for designing building codes, all those purposes. Next, please. And then how it is measured? As we discussed, it is by seismometers, and a seismograph is a device for measuring the movement of Earth, and consists of ground motion detection sensor called seismometer, coupled with the recording system called data logger. The record data is called seismogram. So normally, you might have seen sometimes paper, it comes, this curves comes like the seismograms. So based on the seismogram, analysis is done. What is the magnitude and what is the intensity, where it occurred, where is epicenter, where is focus. Everything can be assessed based on seismometer data. Next, please. And what are the causes? Is what initially, as we discussed, it was thought mythologically by God or some snakes or like that. But later, scientific findings found that it is basically tectonic, the movement of plates as well as movement along faults causes problem. That is what causing earthquakes, tectonic earthquakes. Volcanic activity like Tonga, the eruption caused earthquakes 2 years back. And meteorites also, if the large meteorites hits, there will be some earthquakes. And changes in loading of reservoirs called reservoir-induced earthquakes. So this is what sometimes we see near Koina, in Maharashtra, in Idukki, in Kerala, because it was found that when the loading is more than 100 meters thick water column, there is a likelihood of earthquakes, but not very high magnitude. But sometimes it will be adequate to cause damage in the neighborhood. Then collapse of underground caves, tunnels, so collapse earthquakes. These are the types of earthquakes and causes also. Next, please. This is what very interesting slide because you are all aware. Earth is very dynamic. Out of the 4.5 billion years age, the continents have moved so many times. And this was latest single continent, which is about 240 million years back, called Pangaea, where all the continents are together, and one ocean called Panthalassa. And you can see from here again started breaking up. The Gondwana land, the Eurasia, all started splitting up. Then it moved. We have now, as we all know very well, the plates are still moving, and we have a most disastrous earthquakes or volcanic activity along the circum-Pacific belt. Next, please. Yeah, this is a plate tectonics concept. Once again, coming here, how the plates are moving. Little up, sir. The lithosphere, the stratosphere, the thickness, what happens like that when it moves, and what is the force which is really creating problem for the terrain and the earthquakes, how it causes. Next, please. And of course, where it occurs, we have discussed basically in the margins of the lithospheric plates, like our Himalayan terrain. It may be Japan, it may be Indonesia, Mexico, Philippines, Turkey, Syria. Most vulnerable type areas because they are along the orogenic belts, mid-ocean ridges, and oceanic trenches, where the plate is continuously destroyed. And island arcs, you may be knowing, regularly there will be earthquakes in all this area, Japan, Philippines, Indonesia, etc. In Indian subcontinent, earthquakes are associated with the Himalayas and connected mountain chains. The Himalayas is a young mountain compared to our Western Ghats and Eastern Ghats, which are 3,000 million years old. Himalaya is only 25 to 30 million years old. And it is a continuously growing mountain because Indian plate is colliding against the Chinese plate and getting destroyed under the main suture zone, which is causing problem, and earthquakes and landslides are very common. And peninsular India also earthquakes occur, even though it was considered as more safe, that is South India. But earthquake of some magnitude, which is 5, 6 like that, are occurring due to the movement along the fault lines, the cracks in the country rock, which becomes activated. The 6.3 Latur earthquake of 1993 is a classic example of recent peninsular shield earthquakes. And there is earthquake near Bangalore, that is near Simsha River 5.2 in 2001. And we had earthquakes in Idukki area also, Palakkad also, Bellary also, like that we had a lot of earthquakes, but all are 5.2, less than 6. So most devastating was the Latur earthquake in 1993, where a few thousands of people died, not only in Maharashtra, in Karnataka also. But now the faults have become active. Even Jabalpur earthquake, 1995 also caused problem, which is actually along the Narmada fault zone. Next, please. This is a global plate, the current situation of the plates and their boundaries. Because interestingly, plate consists of both continents and sea. It is not only continents. So it is actually combination of both. And they keep on moving, not only the continent, along with the plate, it moves. And there are some areas where it gets destroyed, Some areas it gets accreted, like mid-ocean ridges. I'll show some images later where it gets continuously materials added from the mantle. Some areas getting destroyed, like Himalayan terrain I told you, or circum-Pacific belt near Japan, or even Indonesia, Philippines, where the plate boundary actually gets destroyed regularly in the Benioff zone. Here it is mid-ocean ridges like Mid-Atlantic Ridge or Carlsberg Ridge. Continuously the ocean floor is added and plate material is added. All these are very active areas. Next, please. This is a global seismic hazard map because actually, as we discussed, we cannot predict earthquakes, but we can find out where earthquakes occur more. So a hazard map has been prepared for entire globe. This shows the areas where earthquake hazard is there and which are more vulnerable. So it, as I told you, it is basically circum-Pacific belt or ring of fire is the place where it is maximum. Then Alps, Himalayan mountain belt, they are also more vulnerable. You can see the picture. Next, please. With the earthquake occurrences you see. And this is actually, next go, sir, no problem. This is the number of earthquakes, what happens regularly. Very minor. It is estimated around 13 lakh annually. Minor up to 3.9 is 1,30,000. And major only, it is around 17. Great will be 1 per year. That is above 8 magnitude. This all based on observations 1990 some are based on observations 1900 onwards. Now, of course, there is a good documentation. Globally also, we have a large number of seismic stations and we have GPS stations. Now, data recording is quite good and more accurate. Next, please. This is the earthquake where it occurred and what is the magnitude. The dark one is the large ones, which is actually few compared to the smaller ones. Next, please. This is what I wanted. Of course, I'm sorry, the maybe slide may not be visible clearly. If you see that center portion of the sea, lot of horizontal lines are seen. They're all called transcurrent faults. Major ones, hundreds of kilometers long, and along which movement takes place. Plate movement takes place. Plate material is added regularly along these major transcurrent faults. They're all highly vulnerable. And if it's a top area where that the circum-Pacific belt trenches are seen, deep trenches. Basically, it is deep areas where plate material is getting destroyed. That is what causing the volcanic eruption as well as earthquakes. This is basically Japan, Indonesia, Philippines, that area. Next, please. This is a closer view of the Mid-Atlantic Ocean ridge, where Indian Ocean ridge and Middle both have this Indian Ocean ridge, where you have a lot of transcurrent faults and such activities. Next, please. Yeah, this is again Mid-Atlantic ridge, where this we see center portion. Actually, there's a ridge. Throughout, there is a ridge actually, thousands of kilometers long, and where plate material is continuously coming out and sea floor is spreading. And this side, Africa or South America or North America side, the plate getting destroyed or the material is going inside the mantle. So this is a continuous process. But all I want to draw the attention, it is very, very small speed, like few millimeter per year. You will not realize it is really happening until you record it using GPS or geodetic measurements. As it feel nothing is happening. As far as common man is concerned, nothing is happening. But this a few millimeters per year, it is happening as the recorded data is clearly showing. When the movement increases large quantity, it becomes rupture, then earthquake occurs. That's one way the earthquakes are predicted or modeled now. Next, please. This is where India, the major earthquakes occurred. I told you the center is the we are seeing is that our Latur earthquake, and we have Bhuj earthquake in the Gujarat region, and all of us are actually in the Himalayan belt, in Assam, in Bihar, in Nepal, Himachal Pradesh, Uttarakhand, then our Uri earthquake near Kashmir, like that. it is very common. Himalayan terrain or major earthquakes are very common. Now also, as per seismic gap analysis, some foreign seismologists are warning there will be major earthquake in Himalaya. It's going to be above more than 8 magnitude. But of course, there is no proper evidence for that it will happen. No proper evidence. But that is the way seismic gap analysis they have done and warned. India, as I told you clearly, and Andaman Nicobar also certainly we have a more one earthquake here, and it is also more vulnerable because we are close to the circumferential belt and trenches. So we have more vulnerable areas in the Himalayan region, Kutch and Andaman Nicobar. South, of course, not that much bad. This is the seismic zone map of India, based on the basically intensity. This map is prepared by Bureau of Indian Standards. Initially, we had zone 1 also. They modified after Bhuj earthquake, and they brought out a new map where red indicates zone 5, very high risk zone. And next, zone 4 is high risk zone. Zone 3 is moderate risk, and zone 2 is low risk. Basically, as I told you clearly, Northeast and part of Himalayas and Gujarat are high risk, and most of South India and Indian Shield is low risk. Means magnitude will be less actually. It is 4 and lower, the intensity. Next, please. And recent Turkey earthquake, I think all of you might have read in newspaper. One of the most devastating earthquake occurred February 6th, and morning and afternoon. Afternoon was 95 kilometers away from the first one. It is Turkey and Syria, and it damaged around 350,000 square kilometers, double the size of our state of Karnataka. And 1.4 crore people got affected, and more than 57,000 died, 50,000 Turkey, and 7,000 Syria. It's the deadliest earthquake experienced so far. Houses collapsed, a total devastation. So there is no other word actually. Next, please. This is the image, satellite image, pre and post. See how many buildings are there, but the post image, we are only seeing clear ground type, totally cleared. That was the impact of this earthquake. Next, please. This is what happened in 99 Turkey earthquake. Turkey is known for vulnerable earthquakes like this. See, one entire portion has gone down, not seen at all. Izmit area. So this is the way the earthquakes can damage entire infrastructure and nation itself. Next, please. Tsunami and earthquake affected Osaka and Sendai, Japan. You all may be remembering, even it affected Fukushima reactor also, because they built a wall of 6.5 meter to avoid tsunami. But this earthquake caused tsunami, which caused more than 7 meters high waves, and Fukushima reactor got affected. And still the controversy going on whether to revive it or not. And you can see the images clearly before and after. Such a devastating earthquake was this one. Next. Yeah, next. This one, next. Yeah, this one that, I'm sorry, this is a PDF, we are not able to show the animation. It's like the 2004 December 26 earthquake, 5.2 magnitude, which occurred near Banda Hatch in Indonesia, which affected large portion of India also and many countries. Banda Hatch alone, around 1.5 lakh people died. India also more than 10,000 people died. Tsunami affected. Next, please. This example you can see. The top is before earthquake, bottom is after earthquake. It looks like skeleton. The Banda Hatch area, which is very close to the epicenter, and tsunami as well as earthquake both killed lakhs of people in Banda Hatch, Indonesia. It is close to Andaman Nicobar actually. Next, please. These are tsunami affected areas in India. I'm sure most of you might not have heard tsunami word before this event. I still remember that day, 26th December, Sunday, after the Christmas. Around all people are really relaxing and enjoying. TV news came, I remember around 8:30, giant waves hitting Chennai. So there was a confusion, what is this wave? Because later it became tsunami. The two waves, it damages so much. More than 10,000 people died, destroyed all the buildings. I visited Nagapattinam after tsunami. I still remember it was like some demon has walked on the houses. All rubbles only, except one or two very strong stone buildings. All are totally damaged. And that Nagapattinam, on railway track, I'm seeing hundreds of boats arranged as if somebody is arranged for show. It was actually brought by tsunami. Velangani church, up to second floor water has come. And water came almost 3 kilometers inside. So it was one of the most dreadful tsunami and earthquake impact during that. That really taught us a lot of lesson. And Vijay sir remembers very well, I know NDMA actually became more active after this event. 2001, after Bhuj earthquake, NDMA was, or NIDM started activities, but NDMA actually become more and more active and more planning after this tsunami. Next, please. Next.
How it affect Kerala?
What is that?
How it affect Kerala?
It affected Kerala. It in our Kollam area, the Kodangalore and our what you call Karunagapalli, all houses got washed away. Death toll was less, fortunately, because by the time it deflected and reached Kerala, it was late, 11:30, 12. People were aware of that there is a tsunami. So, but unfortunately, that Amrandamai Ashrama, that area, also got affected, and they had built a lot of Nadamra houses on the beach side for fishermen, all got washed away. And it took even up to Kasaragod, Panambur, Mangalore waves came, but not very high waves. That's the advantage. Now, unlike Tamil Nadu was of height of coconut tree, 30 feet, 35 feet. Next, please. Next, yeah. Next. Yeah, sorry. Previous. Go previous. Yeah. Indian earthquakes, because we discussed, again I will highlight Latur or Killar earthquake of September 13, 1993. 6.3 magnitude. Chamoli earthquake, 1999, magnitude 6.8. Bhuj earthquake, one of the most, again, disastrous. January 26, 2001, magnitude 7.7. This I remember. The school children who were taking procession in Bhuj and in narrow gullies all died due to this earthquake, as buildings from both sides collapsed on them. The most disaster and killing earthquake area. And even Ahmedabad, which was around 400 kilometers away from Bhuj, many houses collapsed. Many buildings collapsed. Some 400 people died in Ahmedabad also. And it affected most part of Gujarat because the 7.7 magnitude earthquake. And our poor construction practices and along the valleys and low-lying areas of that soil type, which matters a lot, came to picture. Liquefaction took place in many areas. Then Jabalpur earthquake, 1995, also caused problem. Uri earthquake, 2005. Nepal, the recent 2015 also caused problem in many parts of Bihar and Nepal. And tsunami, as I told you, it is one of the most dreaded damage disaster which India saw in 2004, when a lot of people got affected, houses damaged, and coastal regulation zone, what we had prepared earlier using satellite data, was actually afterwards revised. It became including height information and coastal management plans. And I'm very happy that a lot of people use the input for identifying location for rebuilding the fishermen colonies in a better place using this data. But damage has been already caused. Next, please. Next. Next slide, please. No, I think I have some good visuals. By earthquakes. Okay, no problem. Because I have some good satellite pictures. Okay. I think earthquake is causing damage for presentation also. Coming now. We'll have the satellite pictures of the damages. It's okay. I think I don't know whether are you able to see slides?
Yes.
Okay. So, sir, previous slide you can go. Previous slide. Okay, no problem, sir. Actually, I have a good picture of damage.
There is one girl who is in the presentation mode. That is affecting the problem.
Which one, sir? I don't have any movie, sir. It is only picture. Okay, no problem. It's okay, sir. No problem. This is actually where that Bhuj earthquake occurred, that area, the liquefaction, how the soil there became liquefied, and you can see the cracks developed and how it changed, impact on ground. It is very close to the epicenter where the earthquake occurred. No? That's very close to the epicenter. This picture has been taken, ground photo. I had some satellite picture before, but that is missed. Okay, next, please. No problem. Yeah, this one, after these are the images of Bhuj earthquake satellite images. You can see the damage caused in Bhuj area. So much destruction. So many buildings collapsed, even hospitals collapsed. So that's the way earthquake can cause damage. Next, please. Yeah, this is the liquefaction, the location where it really earthquake epicenter is there. Next, please. Yeah, this Uri earthquake. So much damages. Of course, this is a hilly terrain, so we are not able to see as Bhuj what we saw. A lot of buildings here also collapsed in the Uri area. Next. This again, that China earthquake, how it caused the pre-earthquake, post-earthquake. There's a lot of changes. Image may not be that good because we are not able to see a full resolution. Next, please. And of course, now I just wanted to highlight what are the different methods to study earthquakes. Because even though there is no proper method to really tell when an earthquake can occur, but there are so many efforts to understand earthquakes. This actually one is seismic risk zone mapping that collects integration of geological, structural, seismological, geographical data. Then we can identify where earthquakes occurred more and extrapolation so that we can tell there is a likely earthquake of this magnitude this time, or this area will have this type of magnitude. And like we discussed, tectonically active areas are certainly more dangerous than not tectonically active areas. Fault areas are more vulnerable. Like that, seismic risk zone is the one method adopted. Next, please. Seismic gaps. Like in a known seismic belt, normally there's a movement happening. It may take 40 to 50 years to really accumulate the total movement and break or rupture. So if a long time there is no earthquake at all, so there is a possibility of earthquake coming there. That's what now some seismologists are predicting, that there is a likely earthquake in the gap region between Uttarakhand and Bihar. But it is not precise estimation, not possible at all. Next, please. Geodetic surveys. It is more precise, but it is basically measurement of deformation, displacements caused due to plate movement by tectonic activities which build up strain. Repeated ground geodetic surveys are expensive, time consuming, and because of that, it is not practically used everywhere. That is a basic drawback of this method. This is quite useful actually. Next, please. Of course, space-based techniques have come handy and found to be quite useful. Satellite laser ranging, GPS, radar interferometry, satellite remote sensing, increased solar activity. This is actually a new area where you can predict to some extent. Measurement of electromagnetic radiation and electric signals, earthquake clouds, and thermal remote sensing. These are the methods adopted. Next, please. This, of course, I will not go through more details. Space techniques have advantages: global but large area coverage, repeated availability of data, cost and time effectiveness. And as I told you, the first four helps in identifying hotspots, last four one that helps in giving early warning. Next, please. But let us have a frank admitting, there are no generally accepted operational methods for predicting earthquakes at all. Although some success have been claimed by Chinese or Greek or Italy, they are questionable and in any case not sufficiently reliable at all. Next, please. This is what one more attempt we do by studying the past earthquakes. One example I'm showing: seismotectonic map of peninsular India. The dots using blue, orange, red, orange, etc., or pink, etc., are the earthquake occurrences. The lines are weak zones or faults or lineaments. Whether it is associated with some fault, that's what we're trying to establish. Next, please. This is one analysis done for entire South India. IASC and ISRO did together this work, and we found that some are active zones are there. That is going to have impact if you are not taking care when you build houses close to that active zones. Next, please. This is the similar lineaments and fractures identified by entire Karnataka, along with earthquake occurrences, which are more active areas, which are more vulnerable. That is what the purpose of this exercise. Next, please. For Kerala also, because Kerala also there is a lot of earthquakes occurring, mainly as I told in the Idukki region, Palakkad region, and all this. Fortunately, the magnitude is not very high, and effort is made to identify more vulnerable areas so that when you construct buildings, you take care of the earthquake-proof construction so that your building will not collapse tomorrow. Next, please. This one example, actually a study showing near Bangalore some vulnerable areas. Next, please. We went to field also to see that how this vulnerable area really looks in the field. Interesting observation. What I had written L15, actually lineament 15. The entire valley is thick sand and crushed rocks. Either side, it's rocky. When you went and talk to the people, they tell they feel earthquakes very often anywhere it's happening because it's a weak zone. The wave propagation is quite high along this weak zone. Whereas other side, both sides, rocky areas where fracture is not there, where shearing is not there, people are not feeling earthquakes at all, most of the times. So earthquake propagation is more high or amplified along weak zones. So we need to identify weak zones so that we can take more precaution in such zones when we construct, so that damage is nil or less. Because as famous saying is there, no earthquake kills. It is man-made structure only kills. So this is one study we have done for near Bangalore, and microseismic zonation for Bangalore also done. So Sitaram and myself are all involved in this work. Next, please. These are all the different methods. I will not go more detail. The SAR interferometry, then ionospheric precursor, earthquake clouds, thermal remote sensing, because what China claims is using thermal remote sensing. Temperature changes, like what they tell, if the temperature changing by 6 degrees or 10 degrees, previous to maybe a week or 3 days before, 4 days before, on a large area of 1 lakh square kilometer, certainly there's a possibility of 6.5 magnitude earthquake. They're telling they're able to predict, but of course, it is not taken totally conclusive by many of the scientists. But there are some studies done by in India also, after Bhuj earthquake, Latur earthquake. Some studies have been done to show thermal anomalies are there. But warning type studies, we do not have much here at all. And similarly, SAR interferometry also is basically post-mortem type. After earthquake occurs, the interferogram studied, okay, there's a displacement happening. But ionospheric precursors, electromagnetic energy release, etc. Some studies have been done by French, like D-meter satellite, as well as Japanese, which can help to give some 8 to 10 hours in advance warning type. Again, not conclusively, there is a study to show that it is given any warning. But there are some research as new areas come emerging, maybe next 4 decades or 5 decades, you may develop some indicators by studying the ionospheric disturbances, the release of electromagnetic radiations or electric disturbances, because what they tell is when the earthquake is going to happen, some 8 to 10 hours before, crumbling and crushing of rocks happen within the earth. That generates electromagnetic radiation that escapes to the cracks or fractures in the rock, which can be sensed by satellite. But what is the concentration of the gas, concentration of the radiation is not very clear. Some efforts are there, but hope that we'll be able to amplify that and try to find out in advance, at least few hours in advance, this earthquake is going to strike, which will save a lot of life. Next, please. Of course, this is the Indian effort I'm just putting. There is a lot of effort is going on. Seismically active areas using all these methods, satellite data ranging, remote sensing, INSAR, GPS, thermal data, etc. And we have actually the right side you're seeing the images based on GPS studies. We have a IGS network, that is International Geodynamic Study using GPS. We have stations in our NGRI as well as in IAC also, GPS stations. We have in Kathmandu also. The baseline reduction or increase is monitored regularly. That's what you are seeing, -3 plus or -2 millimeter for a year, the moment. But in the plate boundary year, we can see 20 plus or -2. So here the movement is more, here movement is less. So such studies are going on under using GPS, SAR interferometry, and seismometers, geodetimeters, Water Institute of Himalayan Geology, NGRI, and our National Seismic Center. They're all working together so that we will have at least a pre-warning or forewarning that earthquake is going to strike this area, or vulnerable areas known, which is more vulnerable, what method they should adopt to manage it. Next, please. Of course, impact of studies we discussed, but I thought I list it. Houses, schools gets damaged, land, submerged land, changes river courses, cattle, people all die. Loss is really severe. Next, please. Of course, in India, about 59% land is vulnerable, and the Indian plate is moving around 47 millimeter per year. That's a prediction. So there is certainly World Bank and UN report shows estimates that around 200 million city dwellers in India will be exposed to storms and earthquakes by 2050. Next, please. This is all by NDMA, National Disaster Management Authority. Last 50 years, 20,000 deaths have happened in India due to earthquakes, 10 major earthquakes. And these are all major earthquakes list actually. Next, please. Okay, next. Next, sir. This is what the effort by India, National Center for Seismology. And right now there are 155 stations have been established, seismometers across the country. And earthquake monitoring is going on 24/7. And it is really helping. Earthquake seismic hazard micro-zonation also been done now. And messages also sent now. We have a very good network. I'm very confident that within the next 2-3 decades, we'll have a system to give immediate warning as well as system to really predict and forewarn the earthquakes. Next, please. How to manage, certainly is very important for all of us. Study the past events, understand the geology and tectonic area, map land use, land cover, settlements, water bodies, soil, slope, etc. Prepare seismic hazard maps. Now, seismic hazard maps at micro level has been prepared for major cities like Bangalore, Delhi, Calcutta, Jabalpur, like that, which helps in adopting suitable building codes and land use practices. Then you have to educate people about better construction practices, because ultimately, if you construct a building which can withstand earthquake, there is no problem at all. There is a lot of methods have come now. Even at plinth level, you have a beam, it will help a lot, because the basic logic is the entire building should act as a single unit and swing and come back to the original position. Then nothing will happen. And at the foundation level itself, you can separate the building, top building from the foundation, so that propagation of the dangerous waves doesn't happen. That is by rubber bearing, as well as now new methods like mixing tire pieces with the soil, etc. are adopted now. So there are a lot of improvements are there in construction practices. Cost will be little high, but it will save us. And we have advantage, educate, create awareness about measures taken. And now a lot of effort is by National Disaster Management Authority, State Disaster Management Authority, and National Center for Seismicity, and Karnataka also has got the Karnataka State Natural Disaster Management Center. And they're really doing a wonderful job now, and they're going to do a good job, and research also is encouraged. Seismology Institute is there. So coming years, we'll have better earthquake management. Next, please. Of course, these are all what to do. I think I will not go detail. Next, please. This is what the Indian Seismic Network session for entire country. We have 3 in Kerala, Chottupalli in Idukki, Trivandrum and Kochi. Karnataka also around 12. So it's a good broadband seismic station network which records any type of earthquake immediately. Next, please. This is what yesterday there were some 4 earthquakes. One in Vijayapura, that is earlier Bijapur in Karnataka, 3.1. Then Chengalpattu, Shillong, Rajkot. All are below 4 magnitude, so there is no danger at all. But this seismic network records and immediately gives the information. Next, please. This is Awaji Earthquake Museum in Japan. Very good example we need to follow in our country, because in 1995, Kobe earthquake killed thousands of people in Japan. Which was really surprised, because as a geology student, we all studied that Japan is well prepared to face earthquakes. But it was really not so. 6.5 magnitude earthquake killed thousands of people. Even bullet train got damaged. But they learned lesson. They built a very beautiful museum called Awaji Earthquake Museum, where they made a lot of educative material, how to building construction onwards, how to prevent ourselves from during earthquake. And most of the people, volunteers or people who are explaining there are people who got affected by earthquake only, and others also. And they made mandatory that all school children of Japan should visit this. It was one of the mandatory must there. It really helped. And now recently I was reading Japan, now around 87% buildings are earthquake proof. And they are well prepared because it is one of the most vulnerable area. And they learned lesson after Kobe earthquake. That's why Fukushima did not kill large number of people. Earthquake. So like that, we also need to have one such earthquakes. We have suggested during to NDMA at the time, but I don't know what happened. It is not happened yet. If it happens, at least people be aware. Next, please. Of course, we cannot prevent natural earthquakes from occurring, but we can significantly mitigate their effects by identifying hazards, building safer structures, and providing education on earthquake safety. And let us build safe buildings so that death toll is less. Thank you. I'm sorry, I think I could not show all the slides and explain because of technical reasons.
Good evening, all of you. Okay, it was a very wonderful talk, as you say, but for the problem of the slide showing, everything was quite good. Of course, the challenges of predicting or forecasting this so-called earthquake is not a joke at all. Really, not able to understand the theory behind the earthquake origin itself. A lot of things are being done. Of course, from the remote sensing, we talked about GPS, we talked about electromagnetic waves, we talked about aerospheric related, everything we talked about, okay? Things are going on, seismography is going on very well, seismic network is being talked about, but you're not able to really catch that particular source. Because if you're able to identify the location and the intensity of that particular event, how it propagates down the line, you talked about P wave and S wave. P wave goes very fast, like a speed of light. S wave goes slow. If the P wave is captured earlier, you can give an early warning signature to the people. Not many minutes, or few minutes can be probably there. You can probably save yourself coming out of the building, or maybe you can switch off the lift, you can switch off the trains, you can switch off the power system, gas pipeline, everything can be done. So early warning is very important element in earthquake. That is the resultant component of understanding the technology itself. Okay, a lot of things are involved. I think Ganesha has made a lot of effort. He has brought out so many slides. I'm sure that the student community would have got some inkling. May not be very detailed way, but I think it's very, very important to know how to grow in the coming years, because these children are going to see many more such events, because the climate change is also going to give yet another shock for them. I was just remembering when Ganesh talked about Japan earthquake. That was one of the examples, I should tell you, 2011, when the first Tohoku earthquake occurred, created a tsunami of more than 7-meter tall waves. It crashed into the Fukushima Daiichi nuclear power plant. Unfortunately, that time power went off. They could not cool the plants there. They became very warm. Radioactive elements also got into the picture. See, a tsunami created by an earthquake that caused a big accident in the nuclear plant. The cascaded, compounded disaster became a globally monitored one, big one. So I think India should be prepared, because the part component what he mentioned was the Himalayan sector is going to be one of the dangerous places, and India has to be prepared at all. And I think this gives you a scope for people to understand the sites of earthquake prediction. I should also say, Ganesha did not talk about prediction versus forecasting. Okay, we talk about weather forecasting, but when it comes to earthquake, we call it earthquake prediction. prediction is more definite. Okay, it's not easy. But we talk about earthquake prediction. Ultimately, these are the events, these are the science and technology components which are really captured one by one probably in the community. I'm sure just like weather forecasting, which took 40 years or so to understand and model. The earthquake also will be probably captured in the coming decades. And young children who are listening to the particular talk today probably will be contributing to that particular modeling tomorrow. Thank you for a nice talk, Ganesh. Thank you.
Okay, my question, I joined late. I want to hear Ganesh talk about. My question is this: how accurate is the prediction now, earthquake? In what time frame you can predict? And the third point, this is what Kalam used to say: if you can predict, you have done a good job. One more observation I read all the time, that the animals behave very funnily before an earthquake occurs. Is there any correlation in that? I really want to know what is the status of earthquake prediction now. Can you throw some light on that?
Sir, it is not possible, sir, now. It is very clear. We cannot predict any earthquake anywhere.
Sir, astrology says that. Say they predict it.
No. Astrology also cannot predict. If they predict, they'll become what you call billionaires. So they cannot predict even a winning election. Leave it, sir. So what I'm telling you, there is no foolproof method to predict earthquake at all. There are efforts, as I told earlier, using thermal remote sensing, as well as electric signals, electromagnetic radiations. But what is done is hazard and risk is assessed. Where there is an earthquake zone, it is identified. What the likely risk is identified. So we know which area earthquake is going to occur. When, what magnitude, we don't know. So what is done now is take precaution while constructing your building, lifeline buildings, dams, anything. You build such a way that it withstand earthquakes of 8 or 9 or whatever magnitude. Like Theri Dam, you may be knowing a lot of protest was there because in earthquake zone. Ultimately, that protest led to building up to, it can withstand 8 magnitude earthquake. But if 9 comes, we don't know. Like Fukushima, what happened? They built a wall which is taking the previous records, 6.5 meter high wall, so that seawater doesn't come even during tsunami. But tsunami wave came at 7 meters. So we don't know. The foolproof method is not there. We are not able to predict. Forewarning or recall that what Dr. Jairam sir told, like by studying the P waves, primary waves, which can travel fast, it travels faster from globally. We can warn little before early. So there are some systems in Japan which gives a water will be bound, immediately everybody will come out. So death toll can be avoided. So right now we don't have any method to predict earthquake at all.
Yeah. What is the lead time? What is the lead time you can warn?
No, sir. Actually, strictly speaking, it is better to construct your building safely than any prediction. As of now.
That is okay, sir. That is a passive way of.
Not passive, sir. That is the only way.
No. After the effect, you are preventing all the thing.
Yeah.
I am asking. My question is very specific. How much earlier you can give a warning? Now, current state of technology, I am asking that.
Sir, it is in Japan, it is around, we can say, some 30 to 40 seconds before, not before that.
That's useless. Okay.
So it's even, sir, life is saved.
Okay. With AI and all that thing now, they are bringing all the past data. Past data you bring.
No, I agree with you.
I can add one thing there. When the tsunami occurred in 2004 in Indonesia, it took definite time to come to Kerala. Okay, it took 2.5 hours or so.
Yes,
they got a lot of time.
But tsunami is okay, sir. I am asking earthquake.
Earthquake only. Earthquake gave.
Yeah, tsunami has to travel through water, right?
Yes,
hydrodynamics is involved. Yeah.
Earthquake is what and when, what magnitude, where it would occur. Nobody can tell even today. That is a state of art. On all the animal behavior, it's only theory. It has not been proven at all anywhere.
Sir, I will add on that, sir. Animal behavior nicely raises this point. So what happens once Earth starts shaking? The burrow animals like rats, snakes, all will come out because Earth is shaking already, mild. So they save. So actually, they are strongly footed on the ground, whereas we are not footed on the ground. This we don't realize. They really early and they come out. Not that they predict.
No, they show some funny behavior before the occurrence of an earthquake. That's what I read.
Sir, that's what I'm telling you. We have after Bhuj earthquake on Nair, I remember he claimed that he predicted this earthquake by barefoot walking in Bhuj area for a long time. But he never published before the earthquake.
Okay. Thank you for you throwing light. So
Okay.
I know it is not there. So the people should work on that area. That's what I
Yes,
want.
sir. People should work. Yes. Maybe probably we need to know more and more about interior earth, sir. That is, we don't know much. Once we know that, we'll be able to understand better. Like Ganesha told, if you know what is interior earth, we'll be able to know what is the process which really actually leads to earthquake. Then we will have better prediction models or prediction methods.
Today we don't know what is happening below the 15.
Yes, sir, we don't know.
Yeah. Thank you.
It's okay, sir.
Okay.
I thank you. I typed the question because this time is running out. I think we should give priority for students. I know that. So basically, in the presentation somewhere you mentioned about study of variation of solar activity in this context. So I just wanted to understand the relation of variation of solar activity with earthquake. That's all. That is the only question I have.
Actually, what happens in Russia, intercosmos data, they studied and they found that before earthquake, there is an increase in the ionospheric perturbations in the and solar flare is increasing. It is only one paper, two papers, sir, not really.
Oh, fine.
I'm
Very
being
nice.
honest with you because I collected research paper and all these things, sir. I
No,
find
you are right
something-
because we have to exhaust all aspects.
Yes,
You know,
yes.
definitely.
Yes, sir. No conclusive evidence, sir.
Okay. Thank you.
Yeah. Sir, almost if we see 2004 when we had the tsunami, now it is almost 20 years as
Yes, sir.
passed. But any learnings have been done, or we say that we are the progressed in this area so that we will be able to have at least some idea about the earthquake or like what you say, yes. Whether you are being in that region or are we sitting in that fault line, other things are all right. Other than that, is there anything significantly has been brought out? How do we say that earthquake, or at least a tsunami, it is some time it takes, a definite time it takes, because it has to travel along the sea and then we can get alerted. But this earthquake, it's really a problem. Is there anything has been done in these 20 years, sir? That is.
Sir, I think a lot of things have been done because National Disaster Management Authority and the National Institute of Disaster Management, each state has got now State Disaster Management Authority, and a lot of research also been done. And awareness has been created among contractors, mestris who construct houses across country, wherever earthquake vulnerable areas, to build houses which are more resistant, which can withstand earthquakes. That's the first thing really it is done. And we have a national seismic station network. 155 stations are there. Data is collected. And we have a disaster rescue force is there now. And even after tsunami, the new buildings constructed for fishermen at height, actually, not in the low-lying area. And even Bhuj, basically, rebuilding has been done, adopting a lot of modern techniques and the separation methods from foundation to building. A lot of things have been. Micro-seismic zonation for major cities has been done. A lot of things have been really being implemented, sir. It is really, there is a Bhuj earthquake and tsunami. Gave a real change to Indian thinking about disaster management, sir. We are doing good. I'm confident that next disaster will not be that damaging as what we had earlier.
Thank you, sir.
some problem I had. Time is running out, as I said, and our Ganesh Raj has given an excellent picture about what's all happened, what's all happening, and what are the possibilities and what are the impossibilities about prediction of earthquake and things like that. In fact, I wanted to say my own experience. I had experienced earthquake in 1967, December, Koyana earthquake.
Oh.
I was in Pune, sleeping in a first floor of a house, and the window rattled and came down running in the middle of the 2 a.m. in the night, and experienced it. And from there onwards, I have seen a lot of activities, including Idiki Dam people, trying to find what are to be done. And I was working in an organization called Central Water and Power Research Station, Pune, where they have an excellent earthquake engineering division, seismology people, Dr. S.L. Banerjee, S.K. Guha, and people like that in those days. I'm talking about 1960s, late 60s. And, and then, of course, I experienced tsunami also. See, I was in Kannur attending a wedding near the beach, and I saw how tsunami affected there and all that. But then, these are all mitigation is the only way. As Dr. Ganesh Raj said, mitigation is the only method by which the population can be saved out of the disastrous effect. That is the only thing I can say. Lot of things are happening, but then, predicting it is becoming a thing which is, I think, not finding a solution, despite what Sundararajan said, artificial intelligence and various things. So that is only, I think the youngsters who are listening to it is resolved to find methods to predict earthquake, at least in some few minutes in advance, if not hours. So thank you very much, Ganesh Raj, for coming and giving such a nice talk. Thank you very much.
Sir, only update here. Koyana region, now what they have done under MOES, Earth Science Studies, they drilled a deep hole, and underground they set up seismic stations and study the movements within that. The latest development in the last few years. A lot of real things are happening. I'm really thinking that maybe next 2-3 decades we'll have some solution in this direction.
Thanks for the update. Good update. Thanks for that.
Yes, sir. Am I audible? Yes, sir. Good evening, all. My name is Devananda Shrijit, and I'm here to conduct the question answer session. And before that, I'd like to thank Ganesh Rajan sir, PJ Bhatt sir, Kutti sir, and all our special guests here. And I must say, it's extremely a delightful day for us to have you all here. So moving on to the question answer session. The first question is from Jamal, and they're asking, what are the reasons for the cause of earthquakes?
I have explained a very detailed. It's basically movement of plates. Means that a thick continent plus ocean, around 100 kilometer thick plate tectonics moving on one another and getting destroyed in the trenches, getting added in the mid-ocean ridges. They're all basic reason for tectonic earthquakes, and volcanic earthquakes are different. And sometimes it is caused by even collapse of tunnels, like that's minor earthquakes. Major is tectonic earthquakes. I think the notes clearly explains. You can go through that. I hope Jamal can go through my notes, which gives elaborate reason for cause of earthquakes.
Yes, sir. And the next question is by Adil Prajeet CP. and he's asking whether Aravalli Mountains are formed by the collision of Indian and Chinese plates.
No, Aravalli Mountain is again a old mountain belt like our Western Ghats and Eastern Ghats, which are around 3,000 million years old. There was a basin, this actually means like a river basin type. Sediments were there. And that sediments got as a folded belt that became Aravallis. They're not because of the movement of Indian plate.
Yes,
Next
sir.
question? Yeah.
And then we have another question that is, can earthquakes be predicted? And if not, why is it so?
We have discussed enough. We cannot predict. It is youngsters like you should develop some new methods to predict, and we'll be really glad because it is an area where matter or information is quite inadequate, especially in the earth, the process, what it leads. We do not have much information, and we are not able to really synthesize and find out when it can occur, what will be the magnitude. And it's a challenge to youngsters like you.
Yes, sir. And then the next question is, what is the intensity of an earthquake?
Intensity is basically the damage caused, or like Kuttisar told, he felt. So that is what intensity. Feeling, like you felt some shaking is happening. Next you feel tables are shaking, window is rattled, building collapse. Intensity is the damage caused by earthquake is basically measured by intensity. There's a scale called modified Mercalli scale. It has 1 to 12 based on the damage caused. 12 is most destructive, total damage. Only just you felt it. Modified Mercalli scale. Okay.
All right, sir. And then we have another question by Adil Pradesh. He's asking if any continents or countries will collide in the future, and if so, can you name a few of them?
Of course, not in our lifetime. Not in our lifetime. Certainly, there will be collision or going under, destruction like that. You know, maybe needing now. There's a new continent found near New Zealand and Australia called New Zealand. They call now. It is also controversy only. So it will happen, but it's a very slow process, like few millimeters per year. It may take thousands of years or millions of years to collide.
Yes, sir. Adil, I hope you got your answer. And then the question is, are there certain months of the year that are more seismically active than others?
Not like that. It is basically no link with the season.
Hello,
It
sir.
is no links in season actually.
All right.
Yeah.
Then the next question is by Vishwajit, and he's asking whether earthquakes are caused in Antarctical regions.
Certainly, everywhere. If there is a possible earthquake anywhere because the thick ice is there. It may be less because people are not there. We are not recording it, but there are recorded earthquakes in Antarctica also.
Okay. And the next question is by just a minute. Yeah, the next question is what are anthropogenic seismic events?
Anthropogenic seismic events, the seismic event caused by human intervention. Basically, such things are quite low. We cannot tell that seismicity can be caused by human beings. Seismicity, actually, anthropogenic activity may accelerate damage caused by earthquakes because we cannot trigger earthquake from a deep incident into the earth using human activities at all.
Yes.
Some local things happen is like I will just share here. Like I remember what Kuttisar told type only. I was walking in Kasaragod when I was in maybe 1980s. And suddenly there was shaking of the land. Later we came to know there was a huge fire in Cochin refineries. Entire coast shook. Not very damaging type. Entire coast shook. Such things happens. Huge explosion. Put a bomb. There will be some minor earthquake happens and you quarrying when you blast the rocks. There will be some 1 magnitude 1, 2, or 2.5 like that will happen. Not devastating earthquakes. Okay. Any other question?
Yes, sir. And the next question is by Hannah Fatima, and she's asking, what are the updating studies of earthquake in India or around the world?
A lot of effort is there. As I told you, India set up a seismic station network across country, and we have tie up with global players also. We share data, whatever we get, and Seismological Institute is there in Gujarat, which is just doing study on seismic aspects. Globally also, a lot of studies are going on, because main focus is now on to really make buildings safe, retrofitting as well as new buildings safe from damages. But other side is prediction research by various methods. It is going on. It is in a good way. Of course, if we search us in Google, you will get a lot of things. So it is continuous process. It is not a one-time process.
Okay, sir. Then we have a question by PJ Bhatt, sir, and he is asking the variation. How is the variation in the solar activity connected to earthquakes?
I think that I explained, because he asked this question directly to me. It is basically by Russian Intercosmos they monitored this increased solar activity, and then they observed cold weather earthquake during that time. They informed that due to the earthquake there is a possibility of like this. It is not proved beyond doubt.
Okay, sir. Then another question by Hannah Fatima. She's asking, what are the basic updatings of earthquakes?
So I think all they are answered.
Yes, sir.
Okay.
And Dwani P. Raj is asking that will anthropogenic activities cause earthquakes?
No, I explained again. I think you are repeating the same question.
Yes, sir. Okay. And then the next question is, if a small earthquake is coming, then does that mean that a larger earthquake may follow?
Yeah, that is called tremors. It is true in well-known earthquake belts like Himalayas or even the Philippines or this one, there is the tremors in advance. It is true. There will be minor earthquakes before large earthquakes. Yes.
Is it always true or only in certain cases?
Most of times it is true. Even there will be precursor, post-cursor also is there sometimes.
All right. Then the next question is that certain earthquakes have a negative magnitude, and is this said to be an error?
What is that? Can you repeat?
The question is that certain earthquakes may have a negative magnitude. So is this an error, or is there any other explanation?
No, negative magnitude is not there. It will be error only.
Okay, sir. Then next question is, at what magnitude do earthquakes begin to be felt, and when does the damage start to be observed?
The most devastating earthquakes will start at magnitude 6 onwards.
Okay, sir.
Before 6 also will feel. Up to 3 normally we will not feel. 3 and above we will feel there will be some damage, 5, 4, 5, etc. But 6 and above is most disastrous. 8, 9 is highly disastrous.
Okay, sir. And then the next question is, do several levels or several scales of magnitude exist?
No, there are many scales, but Richter scale is what more adopted because it is found very acceptable to all.
Okay.
There's no other scale now followed at all. There are some variations, body wave, magma, like that, some variations are there, but most accepted is Richter scale only. Anything other is modified Richter scale only.
Okay, sir. Then, yeah, I think that's the end of the question answer session.
Thank you. Thank you for questions.
Thank you, sir.
So we had a very, very informative and exciting session. Okay, Sajil Mash.
Sir, can I ask a question? Final one. Ganesh sir, one question.
Yeah.
Normally, after one first earthquake, there are following earthquakes also, right?
Yeah.
Yeah. Can any estimate be made of that, or that is also not predictable? Or
No, sir. What happens? There will be precursor. Like before a major earthquake, normally earthquake of lower magnitude occurs first, a few.
okay.
Then major one occurs. Afterwards, a few more minor ones are there. That is
Yeah, but is it always there, or it may occur, may not occur?
No, most of the times it is there, sir.
Okay. Okay.
It's
But
releasing
we can't
energy.
do it. We can't predict that also.
No, sir. It is basically releasing energy, sir.
Okay. Okay.
That's why what they do, they don't advise you to go back to your house or anywhere immediately at all.
Yeah. Yeah.
After a week only, they ask you to go back.
Dr. Ganesh, I'll add one small thing here.
Yes, sir. Please.
So-called aftershocks, what Dr. Sundarajan is asking.
Yeah.
I think that's one area in which we can do some prediction. Okay.
Ah.
There are things where I find that aftershocks are more than the major shocks. There are even
Yes, sir.
also, so that short-term prediction after the actual earthquake is an area of interest for many people. Already over the world, that's being talked about. Okay, they think that aftershocks can be predicted.
Yes.
So a lot of work has been done there.
Yeah. Okay. Thank you.
Yes, sir. Yes, sir. Ritvik is here.
Yes. So can I start?
Yes, sure.
Good evening. I'm Ritvik, and as a student member of UL Space Club, I am honored to say the vote of thanks of this webinar. So, Dr. K. Ganesha, Ganesha sir, Moderator Sajil sir, Founder E.K. Kutty sir, distinguished guest, and esteemed audience. It is with immense gratitude and heartfelt appreciation that I extend my sincere thanks to each one of you for your invaluable contribution in making this webinar a tremendous success. Dr. K. Ganesh Raj sir, your expertise and profound insights shared during the webinar have been enlightening and instrumental in shaping our understanding of earthquakes. Your dedication to excellence and passion for earthquake have truly inspired all of us. Moderator Sajil sir, your adept holding on proceeding and ability to steer discussion in a direction that ensured both engagement and enlightenment for our audience are commendable. Your skillful moderation has added great value to this event. Founder E.K. Kutty sir, your visionary leadership and unwavering support have laid the foundation for the success we celebrate today. Your vision continues to inspire and drive us towards greater heights. And to our esteemed personalities who have attended this session, I would like to give a heartfelt thanks to Jairam sir, hello. Okay. Suddenly my okay. And to our esteemed guests, your active participation, thoughtful contribution, and enthusiastic engagement have been the cornerstone of this event. Your presence and involvement has added immense value in making this gathering a dynamic exchange of ideas and knowledge. Together, we could all say it was a great webinar and we all learned a lot. And I would, last but not the least, would like to thank Dr. Ganesh Raj sir for giving us a wonderful session. Thank you, sir.
Thank you. Thanks, sir. All the best.
Thank you.
Thank you. Bye.
Thank you.
Thank you very much. Thank you. Thank you. Thanks, everyone.
Thank you. Thank you. Thank you.
Thank you.